Okay, this is section 4.7, and we're going to be talking about isosceles and equilateral triangles today. The whole lesson is about those two types of triangles. So by the end, you're going to be able to do a bunch of different problems with isosceles and equilateral in order to find missing sides and angles. The base angles theorem says that if two sides of a triangle are congruent, so pretty much, if two sides of a triangle are congruent, pretty much meaning that you have isosceles, then the opposite angles are congruent. What that means is if two sides are congruent, then the angles opposite them are also congruent. So this is what I tell kids. That little tick mark right there kind of points you to the angle that is congruent to the other one. So those tick marks kind of point you to the angles that you want to be talking about. So that means that angle B has got to be congruent to angle C. Okay? The converse just says if two angles are congruent, remember we did this in chapter 2 and we're just flipping the P and Q, then the sides must be congruent. The sides opposite are congruent. I'm having a hard time spelling. So if I have two angles that are congruent, then I kind of draw from the corner through them, and that side has to be equal to that side. So that means that AB would be congruent to AC. It's kind of a duh thing. I think most of you would figure out that an isosceles triangle has two sides equal, and if there's two sides equal, then there's got to be two angles that are equal as well. Okay? So a couple of corollaries, just some extra stuff that kind of goes with it. If a triangle is equilateral, then it is also equal angular. That is automatically understood. As soon as you have one, you have the other. So if you're equal angular, then you are also equilateral. You can't have one without the other. Okay? Find the value of x and y. So first I'm going to look at this picture. I'm going to zoom in a little bit just so you can see it here. So I have all these little marks, which mean that all of those angles are equal. Makes this an equilateral triangle, which means that all of these sides are congruent. If that one's 4, then it means that one's 4 and this one's 4. So that takes care of what my y is. Over here in this triangle, if I kind of cover that guy up, I've got two angles right here that are equal, and they kind of point to the sides that would be congruent. So that side's equal to that one. So 4 has to equal x plus 1, which means x is 3. This is the kind of problem you're going to do today. We're going to give you a little bit of information and then kind of expect you to use isosceles and equilateral triangles to get you everywhere else, okay? So in a triangle, we know that all of these add up to 180, and you can do that. 4y plus 7x plus 5 plus 9x minus 13 equals 180. The problem is that you have a y and an x, so we need to come up with a slightly different way to do this one. I do know that they are isosceles. These two sides are equal, which means that that angle and that angle have to be equal. So 7x plus 5 has to equal 9x minus 13. So I'm going to minus 7x over, and I'm going to add 13. So x equals 9. Now I could use that to help me up here. So 4y plus 7 times 9 plus 5 plus 9 times 9 minus 13 equals 180. And so now that I figured out what x is, I kind of went off to the side and figured out what that would equal. Now I'm going to go back and just use it in the other equation that we came up with as far as all of the angles inside of a triangle equal 180. So I'm going to take 180, I'm going to add 13 over, I'm going to subtract 81, I'm going to subtract 5, and I'm going to subtract 63. And I come up with 4y equals 44. So y is 11. So we kind of set up that first problem using all of the triangles equaling 180. All the angles in a triangle add up to 180. We had two variables, so we had to come up with something else that would help us. These two tick marks mean that these angles are equal. So I set those equal to each other, figured out what x was, and then plugged it back in. Last problem. There's quite a bit of marks on here. So this guy first, all these are equal, which means that all of these angles are equal. So if I took 180 degrees in a triangle and divided it by 3, I would get 60 degrees. So x is 60. Now I know that these two angles are equal. So if I kind of went through them, it'd mean that side is equal to this side. So this is a 3. Okay, which means this is 3, which means this is 3. So to find y, which is from here to here, I got to go from 3 through 3, so that means y is 6. So lots of properties today using isosceles and equilateral, equiangular triangles, and being able to just kind of put things together in order to make up an equation.